Can you all hear me okay in the back? Awesome. Yeah, so thank you for joining us. Today we'll be talking about securing communication between meshes and beyond with SPIFFE Federation. I'm Evan Gilman. I work for Scytale, as mentioned. I'm a maintainer of SPIFFE and SPIRE project. I'm here with Oliver.
Hey, I'm Oliver, working in Google for Istio.
Awesome. So today we'll talk about, first kind of kick off with the role of identity in a service mesh. What is a service mesh? Why is identity important in one? I'll toss it to Oliver. He'll talk a little bit about some of the challenges that are presented when you have more than one mesh, or when you have hybrid workloads where you have some stuff that is on a security mesh and some stuff that is not on security mesh. Then we're going to talk a little bit about SPIFFE Federation, how it addresses these problems, and finally a demo, which I hope works, which will show SPIFFE Federation in action between Istio and SPIRE. So I thought it would be appropriate to start the talk with the question, like, what is a service mesh? I thought about it for a while, like, what if I would make up a definition, what would it be? And I was curious when doing this talk at what other folks thought security mesh would be, so I Googled it. Then this is the first thing that popped up. It says, a service mesh is a configurable, low-latency infrastructure layer designed to handle a high volume of network-based inter-process communication among application infrastructure services using application programming interfaces. And so, if you're anything like me, it just like raises more questions than it answers. And this is not a slight on Nginx, it's just the first thing that popped up. I looked at a bunch of other definitions. They were all kind of equally confusing, some better than others. But for our talk, I thought we'd kind of use the simple definition of service mesh is an architectural pattern that provides common network services as a feature of the infrastructure. I think that wraps it up fairly well and gives a little bit more concrete. Okay. So this is the context that we'll use for this talk. And the question that, at least in my mind, this statement elicits is, how do you accomplish this? How do you provide these kinds of services as a feature of the infrastructure and remove those concerns from application? The most popular way to do that is to use a proxy, where all this logic, these network services, and this infrastructure logic is kind of extracted from the application and put into a dedicated layer 7 proxy that is deployed with every application, right? This proxy provides like really convenient control point for traffic coming in and out of that app, and provides that point of control for all those services to be kind of exposed, and we'll talk a little bit about what those services might be. There's a whole bevy of features that these proxies can bring. This is just a few of them. These are some of the bigger capabilities I think folks associate with service mesh. There are others, of course, there are many others, but these are just the ones that I find that are like most motivating. The most common reasons that folks will come and ask about service mesh is for these. And you'll note that there's no shortage of security-related features here. Among them, strong authentication, authorization, and mutual TLS are some of the more popular security features folks look for when deploying service mesh. But in order to deliver on those things, there are some prerequisites, of course. If you think about authentication, authorization, it's all about, like, can A talk to B? And how does B know that it's really A that is requesting this thing? So it becomes clear that in order to answer that question, you need like a clear definition of what A is and what B is. So you need identity, and we call that service or workload identity. And that's where SPIFFE comes in. SPIFFE is an identity framework for production workloads. Actually, it stands for Secure Production Identity Framework for Everyone. And it provides this standardized notion of identity and provides these well-defined methods for proving that identity. It actually also provides well-defined methods for obtaining that identity, but those bits are out of scope for this talk today. This is what a SPIFFE ID looks like. It's a structured string, essentially, modeled as URI, which represents a workload's identity. And one way to think about it is like a username for workloads, right? And there's two components of this thing. The first is the trust domain, which is the one on the left here, the one with the blue underline, and then the second one is the path with the green underline. And the trust domain represents the security domain that the workload is residing in. So one example might be staging or production. Right? And then the path represents the name of the workload. And the SPIFFE spec, we're not very prescriptive about the formation of this. You can form the path however you want. You can form the trust domain however you want. We're only specific about the meaning of those things. So next up we have what we call an identity document. It's called an SVID, a SPIFFE verifiable identity document. And this is how we define how you prove the identity to someone else, right? And there are two flavors of this, two ways to do it. One which is based on X509 certificates, one which is based on JWT. For this talk, we'll focus on only X509 SVID. And that's important because X509 certificates can be used not just for authentication, but they can also be used to establish mutual TLS. Now, to create these SVIDs and manage the identities associated with them, you need some sort of authority. Right? In a service mesh, usually you have this centralized authority. That's the most common way to do it. And this is responsible not just for creating and managing, but also distributing these identities throughout the mesh. And this authority is common to all the applications and all the proxies that live inside that mesh. Everyone kind of mutually trusts it and trusts the identities that it creates by default. But this raises the question, what happens when you have more than one, right? Or what happens when you have some things that are inside and some things that are outside, and maybe they answer to different authorities. So the SPIFFE provides, these things clearly need to talk to each other, right? SPIFFE provides this lingua franca over which they can communicate. But you still need to manage these authorities, right? And what are the right ways to think about the authorities when you have multiple meshes or you have this kind of hybrid deployment? So I'm going to toss this to Oliver. He's going to talk a little bit more about the challenges that pop up in these multi-mesh configurations.
Awesome. Thank you, Evan. Okay. When talking about hybrid and multi-mesh examples, what are the use cases, right? We can think about a lot, but there are three typical things that we want to mention here. Suppose I'm running an operation and Evan is running another. We got a deal and we want to federate our services. How do we do that? That's the first use case. Second one is I'm a service provider and I want to expose my service to my tenants. I get a bunch of different tenants. I want to secure the connection with them and allow them to call my service securely. The third one would be I'm, say, running a big company that is using pretty old infrastructure, and I want to adopt the new fancy service mesh framework. I do that gradually so that I want their services running in the mesh, in the new mesh, to be able to still work with their services in the old infrastructure. Then we come to their basic rules you need to consider in terms of the security. So we list 4 of them here. So first, all the identities must be derived from a trusted root, right? You don't want any untrusted PKI to issue identities that pretending to be some identity in your federated network. The second one is trust domain associated with their parties. If I'm associating with Evan, I want Evan's PKI to be only able to issue identities for his trust domain, so that a compromised CA in his trust domain won't be able to have a big blast radius to impact my service mesh identities. The third one is, of course, we want the transport plus authentication compatibility to be able to establish the authentication between the meshes. Fourth one, of course, security policies. We don't want any unauthorized services coming from external to be able to call my service successfully. Okay, in this presentation, we are going to focus on the first 2 items, which are about identities. When we're talking about identity federations, maybe the simplest idea come out is this picture. You share the common root, right? This is common in big organizations. If you have like multiple trust domains as they are running in their different departments, they could share their common root. And you have intermediate CAs that are derived from the common root. They issue certificates for the workloads in the corresponding meshes. Okay, well, that is true in many cases. There are limitations. In industry, independent parties are not likely to share the common root CA, right? And the second one is, if you are going to share the common root CA, you're still facing a problem that your mesh authority are different from the mesh, the authorities for the mesh externally. So we need name constraints on the intermediate CAs. But unfortunately, the name constraints are not commonly used and respected in the industry. Second approach, we come to the multiple independent authorities. So each mesh runs a standalone root CA, and we federate them, right? This solved the problem of the common root CA, but there are also challenges. So first of all, how does the meshes securely exchange the root of trust? The second one, in this picture, how to prevent the root CA2 from issuing the identities for their mesh red, and vice versa, right? Then the solution is what? SPIFFE federation. Let's go back to Evan.
All right. Thanks, Oliver.
Okay.
Yeah, so this cross-domain communication where different authorities are involved is exactly what SPIFFE Federation is designed to solve. Specifically, how to validate identities in other trust domains. And to do this, we define a fairly simple API. And I quote API because at the end of the day, it's really just a simple HTTPS GET. It is not anything complicated. Every SPIFFE trust domain exposes an endpoint that serves this HTTPS request, and we call that the SPIFFE bundle endpoint. And when you call that endpoint, there's a document that's returned which contains the authority's public keys. And this provides the mechanism for exchanging the authority information between each other. Right? Once these keys are obtained, identities from that trust domain from which you obtained them can be validated using those keys. Right? So the SPIFFE bundle itself is just a JWKS document. If you've ever used OIDC before, this might sound familiar. This is an example of what a SPIFFE bundle looks like. And this is what is returned by a SPIFFE bundle endpoint. And you can see in this example that both SVID types are represented. I had alluded before that both JWT and X509 are supported by SPIFFE. But obviously for this talk, we're talking only X509. And the X5C claim you can see there kind of in the middle, which has the ellipses, is normally where a CA certificate lives, but I truncated it out so that it would fit on the slide. But if we zoom out and we think, what does a full picture look like? It's something like this. So we can see that there are two authorities, red authority and green authority. And each authority provides identities for applications and proxies that lives within their respective trust domains or service meshes. But they also exchange information with each other via SPIFFE federation. And this information, the public keys of the authority, are also propagated down to the applications and the proxies. And this allows them to authenticate identities of workloads which are in that other domain. So, when the workload in the red domain encounters a workload that has an identity from the green domain, it has the keys necessary to validate that identity. So this is how SPIFFE federation works kind of in a nutshell. Today, we will show you how SPIFFE federation works in action between an Istio deployment and a SPIRE deployment. In case you're not familiar with either of these projects, Istio is a full-blown service mesh that provides all those fancy bells and whistles that we showed earlier. But under the hood, it uses also SPIFFE for identity. And SPIRE is a SPIFFE implementation. Its sole purpose in life is to create, manage, and issue SPIFFE identities. Most service meshes have a similar component inside them. This project is focused purely on this, does not provide any of the other fancy stuff. So this is a simplified diagram of the demo that we'll show you. On the left is an Istio cluster. And we have this component called IFS, which is the Istio Federation server. And it is the one which exposes the bundle endpoint server and also a bundle endpoint client to fetch bundles from other trust domains. And on the right-hand side, we have SPIRE deployment. And this is just, SPIRE is deployed just on regular VMs. There's no Kubernetes or mesh or anything like that. There is a proxy. But it is not as far from managed the same way that the workloads in Istio are. And on the SPIRE side, the SPIRE server, which is at the top there, built in has a SPIFFE bundle endpoint server and client. SPIRE on the right-hand side acts as the identity issuer for the SPIRE deployment, and on the left-hand side, there's a component in Istio called Citadel, which acts as the issuer authority for Istio. So some keen-eyed folks in the audience might be wondering exactly how this particular connection in the middle is managed and authenticated. I mentioned earlier that this connection uses this regular HTTPS, which means that we can use certificates from a public CA to secure that connection. There's no client authentication or anything like that. But sometimes it is not practical or it is not desirable to use public CA for this. Instead, in this demo, we're using SPIFFE authentication, which is nice because it doesn't rely on an external authority to issue those certs. But the downside is that it does require an operator to supply the CA certificates in order to bootstrap this connection. Now, I'll note that while an operator has to apply the CA certificates to bootstrap this connection, it only happens once. The cost is incurred at the beginning of the relationship. Because once this relationship is established, rotation of those root certificates can happen in band over that same channel. So without further ado, I will pass back to Oliver, who will run through the demo for us.
All right, thank you, Evan. I hope the demo can
Probably not,
work
I guess.
well. Yeah, I don't need that. Let me switch back to a single screen. Sorry. All right. All good? So first, let's introduce the setup. We do have two VMs that are set up for running their SPIRE server and the SPIRE agent plus the workload, right? On the right side, we do have a terminal that is controlling their the Istio. So if I do get pod -istio system, you can see I have pre-installed the Istio control plane in there. And beyond that, I do have IFS, right? This is a new thing. OK, so first of all, let's start the SPIRE server on the left side. Evan has put up all those nice scripts for me so that I can run them. We can ignore the error message here. I don't think that matters. And then let's run the SPIRE, 02, SPIRE agent. OK, so now both the server and the agent are running. Server is there. Just double check. Agent is there. Let me bring up the workload as the next step. 03, start workload. OK, the workload is started listening under 8443 pod on this VM. So now what I'm going to do is I'm going to deploy a sleep pod in their Istio side, which is cluster 1, and use it to call to the VM. So I do have this, let me see, -info. OK, it's going up. OK, now it's up. And I did also configure the service entry in Istio to route the traffic to the external IP address. This is the external pod. And this is the service name where I'm calling. Mesh internal means this is going through the sidecar, doing mutual TLS with the other side, right? And sorry about this. OK. Now I'm going to make the call. So what's the result? It's going to fail, right? Because we have not federated. The mutual TLS handshake will fail because they don't trust each other. Okay, that's expected. Let's federate them. Sorry, I do have this nice cheat sheet over here, because a lot of those comments are not very easy to configure. Okay, let me do this. Okay, we'll improve the user experience. This is just a prototype. Okay, I'm copying the certificate out of the cluster 1 to cluster 2. Right? I go to the SPIRE server and do a 04. Okay, federate. Now it's good. I have copied that into this SPIRE. And then next what I'm going to do is to copy out the certificate out of SPIRE. All right, this one gives me the certificate. And configure that into my Istio cluster. So what I'm going to do is now I'm going to write this into a file. Okay, this is the new one. And then I put this file into the system using config map. Deploy config map. Okay, meanwhile, on the left side, you see this message. That means it's able to successfully call IFS and refresh this configured certificate for cluster 1. Okay, on the right side, I have created this config map. Let's double check. Sorry. Okay, so it does have a trust bundle, which is the base64 encoded PAM file, and also the trust domain, which is cluster 2. This one is loaded by the IFS. Once IFS loads that, it's able to call to the VM, to the SPIRE server, and authenticate it as well. Let's see what's the log. Okay, the log says successfully called bundle endpoint to get the current routes. So that's a good sign. It's able to retrieve the trust bundle from the SPIRE server. Now I can just run this command again and see what's going on. All right, 200.
It works.
It works? Let's do it again. Okay. All right, that's good. This is a very simple demo, but it takes a lot of work. Okay, let's go back. Full disclosure. We do have some workarounds there because this is just a prototype. What we are doing here, I want to mention, is not the final ultimate solution. We are working on the final solutions, but it will be greatly be nicer, and the user experience will be much better. Okay, so but I want to briefly talk about what we did. So first of all, we defined the service entry on the pilot, right? To define the service name, microservice.cluster2.global, and with the external IP. Pilot takes that and extracts the cluster 2 in the middle, and then put that as a validation context SDS name. On the right side, the Istio Federation service consumes this config map. The config map is, I configured that using the root key of the SPIRE server, and configured that to IFS, so that IFS is able to authenticate the SPIRE server. Right? Once IFS retrieves the new trust bundle, it also updates this config map, so that this config map is always reflecting the root of trust for cluster 2. And this one is consumed also by the node agent. Node agent, when it sees this config map, it will extract the cluster 2 name and construct that to the SDS, and use this PAM in the trust bundle, put that as the value. Now the node agent has the SDS named cluster 2, and the proxy also has a CDS that points to cluster 2 as the SDS name. When the app calls to this external service, proxy can just call the node agent to retrieve the SDS, which includes the PAM. And proxy will use this PAM to call to authenticate the other end. And also, I didn't mention it here. This proxy is using its own certificate, which is signed by Citadel, right? To get authenticated by the other end. This is mutual TLS. Okay. One caveat here is we are able to make a call from cluster 1 to cluster 2 now, and we are working on implementation to enable the other way, from cluster 2 to cluster 1. And it's working in progress. Okay. I think that's
pretty much it.
pretty much it.
We've got this, some links up here. If y'all are interested in learning more about what we've done or how this worked. On the left at the top is Istio resources if you'd like to join the Istio community or check out GitHub. On the top right is the SPIRE resources for SPIFFE SPIRE community. Please feel free to join Slack. Everyone is welcome to join. We'd love to have you there. And then on the bottom is some links to some of the demo scripts and stuff that we used here and the Istio Federation server that we wrote for this demo. Thank you very much for coming.
All right, thank you.
All right, question time.
This is super cool. Securing service meshes and beyond. What does beyond mean? Is that off mesh? What applications does that encompass?
It's like off mesh, like understanding that not only between service meshes, but also back into your on-prem infrastructure or onto your bare metal or something like this.
Awesome. Very cool.
Hey, everyone.
Hello.
Usual suspect. Maybe I missed it, but you mentioned that the certificate minted by red or green, I forgot, one could not be used, or one CA in green could not mint certificate as if it was coming from red. So this mutual TLS, at least in demo, I couldn't figure out where it actually checked that the certificate was signed by the other party.
Yes.
Do you want to talk, because that is the cluster discovery?
Sure.
Yeah.
So for this demo specifically, we are using the CDS to control which cluster, which endpoint is using which trust bundle, right? Remember, the CDS is pointing to cluster 2. Cluster 2 only has the trust bundle for cluster 2, which is the VM. So that you won't use like any other like trust bundle to authenticate cluster 2. And for the listener side, we are still implementing that. We need to do a mapping check to check their identity, the trust domain specifically in your identity actually matches their trust bundle that we use to authenticate. So there's always a matching check on the listener side.
To say in another way, the left side, the Istio side, matches on a host header. And from the host header lookup knows this is something in trust domain 2 or trust domain red or whatever, and then picks up the bundle to use for that outbound connection for server validation. On the right side, we use Ghost Tunnel Proxy, which understands how to introspect client certificate to pull the trust domain out. And SPIRE provides Ghost Tunnel with a map of trust domain names and bundles. And so it knows how to switch the bundle to validate the client based on what the trust domain and the presented certificate is. Does that answer? Okay. On the Envoy side, I believe, because that is like the hack, right? Yeah. Ideally, it will introspect the server certificate.
Yeah.
And pull the correct bundle based on the trust domain presented.
I think that's the final solution.
Yeah.
Yes.
To make this work, we have a workaround.
Yes.
Any other questions? All right, I'll be over.
Hi, so this was a really good walkthrough through the mutual TLS side of this. I'm just wondering, how does, like if you have an authentication policy in your cluster and you're trying to do like authorization, right, within your services, how might this work with authorization policies if you want to allow an identity from one cluster into the other cluster through those policies? Is that a part of this?
Yeah. So I can talk about that. You are talking about authorization policies specifically in Istio, right? So we are working on that to support external identities. Basically, we are, for the authorization policies, you encode their identities as the strings for you to check. those strings can be including everything. It includes their trust domain as well. So now it's already supported, I think. You just put your trust domain there. As long as it passes through their authentication part, it gets their external identity. You can define whatever authorization policy is there. So there's no problem there. I think we could also do like wildcard for like all the identities in the external blah blah trust domain. Always allow, always deny, something like that. I think it's you can go back to me and check with our experts in Istio. Okay.
Cool, one last? Or are we all good? Oh, there's one. Okay.
On the SPIRE side, what is the proxy that was used? Did the server just call the workloads API, or was there like an Envoy there?
The server, the proxy on the SPIRE side is a proxy called Ghost Tunnel, which is in the, I probably should have linked it here. It's in the Square organization on GitHub, Square/Ghost Tunnel. It is a very, very simple MTLS proxy that operates at layer 3.4, but is not layer 7. That proxy knows how to speak directly to SPIFFE Workload API, and also knows how to do the federated validation that SPIFFE requires for different bundles. Did that get it? Yeah.
Awesome. Well, thank you very much. A big round of applause for the speakers.
Thank you.